Okay, so we have a couple of important rules for working with exponents that you have likely seen before. We're just going to review them and then practice them. So if we have that a and b are positive numbers so that they can be bases, and x and y are any real numbers, anytime that we have the same base, if you have b to the x times b to the y, then multiplying two of these exponential expressions together is the same thing as adding the exponents. So b to the x times b to the y is the same thing as b to the x plus y. So for example, if we had 2 cubed times 2 squared, well, 2 cubed means 3 copies of 2 multiplied together, and 2 squared means 2 copies of 2 multiplied together. And so altogether, we have 3 plus 2, or 5 copies of 2 multiplied together. Similarly, if you have a division, b to the x over b to the y, this is equal to b to the x minus y. So, for example, if we had 2 to the 5th divided by 2 to the 4th, on top we have this 2 to the 5th we can express as 2 to the 4th times 2 to the 1st. We're dividing by 2 to the 4th. And so we see that this cancels out and we're just left with 2 to the 1st. Okay. All right. If we take exponents of, so if we have an exponential expression like b to the x and then raise it to a power, this is the same thing as multiplying our exponents together. So b to the x to the y is equal to b to the xy. Notice the difference here is that this whole expression b to the x, we're taking y copies of b to the x. And so for each copy, we have x copies of b. So let's take a look at an example to see this. So for example, if we have 2 cubed, and then that quantity is squared, this means we have 2 cubed times 2 cubed, or 2 to the 6th. Okay. All right, so in this case, our exponents just multiply. If we want to combine exponential expressions that have different bases, as long as the powers are the same, we can do it. So if you have a to the x times b to the x, this is the same thing as ab to the x. Okay, so for example, if we had 2 cubed times 3 cubed, this is means 3 copies of 2 multiplied together, and 3 copies of 3 multiplied together. And so we can always just regroup this so that we have, so that instead we're thinking of having 3 copies of 6 multiplied together. Okay. And we can go either way. If we have, if we have an expression that we want to pull apart so that we have different bases, we totally can. If we have 2 expressions that we want to bring together, as long as they have the same exponent, we can as well. Just multiply the bases together. Okay. Similarly, if we have a over b to the x, this is the same thing as a to the x over b to the x. So for example, if we had 1/2 to the 5th power, this is the same thing as, well, let's write this out. This is 5 copies of 1/2 multiplied together. And multiplying across the top, we see this is 1 to the 5th, and across the bottom, we see this is 2 to the 5th. So rather than having to go through and calculate this, we can just take the power. We have the numerator to the exponent over the denominator to the exponent. All right, let's try out these rules with some practice examples.